When an observable sequence emits a next event, you'll typically want to work with that element, such as to transform it in some way. For example, maybe the element is a date instance, and you want to format it as a string representation before displaying it in a UI label. To transform elements emitted from an observable sequence, you use the map operator. Map will transform each element as it's emitted from the source observable sequence. This is similar to the map method in the Swift standard library, except that this map works with observable sequence elements. I'll go through an example of using map in the playground. I'll create an observable sequence of integers using the of operator. And then use the map operator to multiply each integer element by itself. And use subscribe on next to print each transformed element. And I'll just call dispose on the return value from subscribe on next. Remember that subscriptions return are disposable. This prints the expected results. An observable sequence can itself have observable properties that you want to subscribe to. Flat map can be used to reach into an observable sequence to work with its observable sequences. In this example, O1, O2, and O3 are observable sequences. Flat map will flatten emissions from each of those sequences into a single sequence, applying a transform to each element. There is also a flat map latest operator. This is the one you want to get to know because you'll use it a lot. The difference between flat map and flat map latest is flat map latest will only produce elements from the most recent observable sequence. So, as the observable sequence emits a new observable sequence, flat map latest switches to that new sequence and ignores emissions from the previous sequence. In this example, when the O2 sequence emitted the 2 element, O1 will then be ignored because O2 is now the latest sequence. So when O1 emits the 3 element, it is ignored. Same thing with the O3 sequence. Once it emits element 4, O3 is the latest sequence and O2 is ignored. So when O2 emits 5, it is ignored. Flat map latest is quite commonly used with asynchronous operations such as networking. I'll go through an example of this in the networking video. Now I'll walk through some examples of flat map and flat map latest in the playground. First, I'll create a player struct with a score property that is a variable of int. And a dispose bag. Next, I'll create a couple player instances, Scott and Lori, and a current player that is also a variable with an initial value of Scott. I should point out that current player is of type variable of player, inferred from its initial value. So current player is an observable of a player, which has an observable property score. I want to subscribe to the current player's score. Remember that I'll need to first call asObservable to work with a variable's observable subject value, because a variable is a wrapper around a behavior subject. I said a moment ago that flat map and flat map latest allow us to reach into an observable to access its observable properties. I'll do that here. I'll use flat map first. I'll reach into the element, a player instance, access its score variable, and get its observable subject value. Now I'll subscribe to that observable and print it out. Because variable wraps a behavior subject, which replays its most recent or initial element to new subscribers, that value is printed out. I'll update the current player's score value, and that value is printed out. It's important to realize that what I'm specifically subscribed to is Scott's score, because the current player's value is currently Scott. So I can also just add a new value onto Scott's score. And my subscription will print out that value. Now I'll add Lori onto current player. The subscription will print out Lori's score. So what happened to my subscription to Scott's score? I'll add a new value onto Scott's score directly, and it's printed. This is because FlatMap does not unsubscribe from the previous sequence. This is definitely a gotcha to watch out for. If you use FlatMap, you could be keeping a bunch of subscriptions around that you don't mean to, and those next event handlers doing things you no longer want them to do. FlatMap latest, on the other hand, will unsubscribe from the previous sequence and subscribe to the new one, and only produce values from the most recent sequence. I'll change FlatMap to FlatMap latest here. And I will no longer receive new events on Scott, so the 95 I added onto Scott's score is not printed. There are a couple more transforming operators I want to show you. For example, scan. If you're familiar with the Swift standard library method reduce, scan works similarly. Scan starts with an initial seed value and is used to aggregate values, just like reduce. Unlike reduce, which only returns the final value, scan will return an observable for each intermediate result along the way. And actually, there is a reduce operator in RxSwift that works just like the standard library reduce and returns an observable sequence of the final aggregated value. This can be useful for working with finite observable sequences. You might find scan useful if, for example, you're developing a scoring system for a game, such as darts. I'll start by creating a dispose bag and a darts score publish subject. Now I'll use the scan operator and pass it an initial seed value of 501. Instead of passing a trailing closure for the accumulator parameter, as you saw in the slide a moment ago, I pass an operator directly as the parameter. I can do this because the operator matches the function type. In darts, each player starts with a score of 501, and the score for each dart is deducted from the total score. The first to 0 wins the leg. So I'll chain a map onto the result from scan to return the max of 0 or the total. Then I'll subscribe to next events and print out the new total. So let's say the player throws 3 darts on their first turn, and they score a 13, a 60, which is the highest achievable score, and a bullseye for another 50 points. Not bad. The score is reduced by each dart's score and printed. Let's say I wanted to print each dart's score and the resulting total score for each turn. I can use the buffer operator to group emissions. Buffer will hold on to events emitted by the source observable sequence until the specified time span in seconds has passed, or the count of buffered items is reached, whichever happens first. Then it will emit an observable array of the buffered events. Passing 0 for the time span ignores the time span value, and specifying a time span in passing 0 for count ignores count. I'll cover schedulers later in this chapter. I'll insert a buffer before scan. In this example, I'm not concerned with time elapsing, so I'll just pass 0 for the time span. And I'll pass 3 for count. This will buffer 3 emissions from dart score and then emit an observable array of the 3 scores. I've entered main scheduler.instance for the scheduler, which will cause this buffer to be executed on the main thread. As I mentioned, I'll go into using schedulers later in the chapter. Next, I'll use map to print the array and I'm using an empty string terminator because I'll append this printout in a moment, and then return the result of using reduce to sum its values, which will be passed to scan. Now, for each next event, the array of 3 dart scores and the new total score will be printed. Truth be told, the scoring system for darts is a bit more complicated. I went with a simplified version here, and this is a good example of the kinds of chains you can create in RxSwift, each operator doing its part and passing the result on to the next operator. The print statement in the first map is really a side effect. I'll cover performing side effects later in the chapter. There are additional transforming operators available, which you can check out in the RxSwift repo or in the learning resources I mentioned earlier in the course. However, trying to memorize all the operators all at once is a surefire recipe for paralysis by analysis. I'm showing you some of the most useful operators here, and when your needs call for something beyond their capabilities, that's a great time to go explore additional operators.